Hello everyone, it's Red Saber here from Saber C++, and today we're going to be learning the basics of Arduino programming as fast as possible. So let's get right into it. Let's take a look around the Arduino IDE. As you can see, it went ahead and created a program for us when we started up. Arduino programs are called sketches, so you can see it named the program sketch underscore and then the date. In the sketch, it already added some code, which we'll talk about in a minute. This dropdown is very important, as it allows us to select a board connected to our computer. We can upload code to this board and get messages from it on the serial monitor. Select your board, open the dropdown, select one of the options here, and type in what kind of board it is. Now your board is connected and you can upload code to it. Serial monitor is a tool that can be opened by clicking this magnifying glass button up here. We can use it to communicate with our Arduino board. Let's take a look at this code. Here we have two functions, one called setup and one called loop. These are special functions that will automatically be run by your Arduino. So anything we put inside the braces of the setup function will be run when your Arduino board starts up. And anything we put inside the braces of the loop function will be run over and over again as long as your Arduino is on. Every time we get to the end of the code in the loop function, it'll just start over. You notice there's a grayed out line at the top of each function that acts as a note telling us what's going on there. This grayed out line is called a comment, and it's basically just a piece of code that's completely ignored by the computer and the Arduino. So we can create comments that make it easier to tell what's going on in a certain part of our code. All we have to do is type 2 forward slashes, and then we can write anything we want, and it will be completely ignored by the computer. Let's start by creating a variable. A variable is a little box that stores a piece of information. Each variable has three things. First, it has a type, because we have to specify what kind of information our box is going to hold. Next, it has a name so that we can refer to it in our program. And last, it has the actual value that's stored inside the box, which can be changed throughout the course of our program. In this case, I'd like to store an integer, which is a whole number that could be positive or negative. The abbreviation for integer is int. That's the type the variable will be. Next, we need to add a name. I'll call mine my first integer, and then we can set it to a value using one equal sign. I'll set mine to 22. To end this line, we need to add a semicolon, which is kind of like a period in English. It tells the computer that this line is over, and they can start with the next line. We can name our variable however we want, as long as it starts with a letter, not a number, and doesn't include any symbols or spaces. I name my variables using a standard called camel case, which goes like this. The start of each word is a capital letter, which makes it easier to distinguish the words in longer variable names. Another variable type we can use is float, which is a lot like an integer, but it can also include decimals. I'll create one called myFirstFloat, and I'll set it to 1.5, remembering to put a semicolon at the end of the line. Let's create a Boolean variable next. A Boolean is a value that can be either true or false, but nothing else. The abbreviation for it is bool, so we'll write bool, my first Boolean, and let's set it to false, again adding a semicolon. These are three of the most common variable types, but let's look at two more. The next type is a character, which is a single letter. It's abbreviated char, char, so we'll type char, my first character, and then we'll set it to a letter in single quotes. I'll use the letter C. Char variables can only store a single letter, but we can create a group of them to form a word or multiple words. A group of characters is called a string, so we can write string, and then I'll call mine a group of characters, and I'll set it to a group of characters in double quotes. Remember, for characters, we use single quotes, and for strings, we use double quotes. We can also set any of these variables again if we want to, but we have to do it in the setup function or the loop function. Remember that the setup function runs when our Arduino starts up. So let's go ahead and change my first character in the setup function. We don't need to say the type again because we already specified that above. All we need to do is set it equal to something else. In my case, I'll do an exclamation point. And there we go. Up here, my first character is C. But as soon as we get to this point, it's now an exclamation point. So if we look at it any lower down, it's going to be an exclamation point. Now that we have a few variables, what can we do with them? Well, it depends on the type of the variable. For our integers, we can add, multiply, subtract, and divide them. Let's try some math here in the setup function. I'll create an int called plus minus, and I'll set this to my first integer plus 5 minus 2. That's right, we can add variables and numbers, and we can make these equations as complex as we want. So this plus minus variable will be 25. We can multiply variables using the asterisk and divide them using the slash, like this. Int multiply divide equals 10 times my first integer divided by 2. And there we go. Now this will be 110. We can also do the same math operations with the float, but it's important to keep in mind that if we do math with an integer and a float, we'll always get a float, even if the float is a round number. The extra specificity on the float is always carried over. So we can do float lots of math equals my first integer times my first float. So this will be 22 times 1.5, which is 33. So this will be 22 times 1.5, which is 33. But since it's a float, it'll be 33.0. Let's say we want to add 2 to my first float. We could do my first float equals my first float plus 2.0. That's a lot of writing. Instead, we can actually shorten it to my first float plus equals 2.0. We could also do this with times equals or minus equals, slash equals for the other operations. And it'll work out to my first float equals my first float divided by 2, or whatever this operator here is. Let's take a look at what we can do with our string variable. We can actually use the plus equals operator, like we did with integers and floats, with our groups of characters, which we call strings. So I can say a group of characters plus equals my first character. And now a group of characters will be this Saber C++, and we'll add the exclamation point. So it'll be Saber C++ exclamation point. Even better, if we add a number to a string, like a group of characters plus equals 45, then it'll go ahead and turn that number into a string and add it onto the end. So this would be Saber C++ exclamation point 45. So far we can't actually see any evidence of our code running, so let's change that. Thanks to a handy built-in feature called the serial monitor, which we have open down here, we can communicate between our Arduino board and our computer while the Arduino is plugged in. To tell the Arduino to set up serial communication, we can write serial.begin 9600. This serial thing is an object, which is a type of variable, like my first integer, but a bit more complex. An object can have its own variables and even functions. In this case, the serial object has a function called begin, which we can use to begin serial communication. We can give a number to the function by putting it between these parentheses. In this case, the number is the baud rate, which is basically the rate at which messages are passed between the computer and the Arduino. We obviously need to make sure the Arduino and the computer are expecting communications at the same speed, so we can tell our computer to use a certain baud rate using this drop-down here. I've already selected 9600, but we could use any of these as long as we set the Arduino to the same rate. To actually send a message, we can type serial, once again getting the serial object, and then we can type .println, which is short for print line. Inside of the parentheses, we have to provide a string to print out. Let's put in our variable a group of characters. Don't forget to add a semicolon at the end of the line. Now, let's upload the sketch to our Arduino board. Before uploading, the computer will verify that there are no errors in our code, so that we don't damage our Arduino. If we didn't have a board plugged in, we could use this check mark here to verify our code without uploading. But this arrow will get both done at the same time. As you can see, the board printed out Saber C++ exclamation point 45, which is what our a group of characters variable was set to. If we upload it again so that the Arduino restarts, it'll do the same thing once again. Currently, we always do the same thing every time the program runs. If we'd like to change the way the program works based on certain conditions, we can use an if statement like this. An if statement works by checking if the condition in these parentheses is true, and if it is, executing the code inside of these braces. Let's check if my first boolean is equal to false. The two equal signs means we're checking if the thing on the left is the same as the thing on the right. In our case, it will be. Keep in mind that one equal sign is much different. 1 equal sign sets the value on the left to be equal to the value on the right, whereas 2 equal signs compares them. Inside of our if statement, let's use serial communication to print out if statement execute. As you can see, it's still printed out Saber C++ exclamation point 45 up here, and then it printed out if statement executed. If we set my first boolean to true and upload our code, we'll see that it doesn't print if statement executed anymore, because this condition is no longer met. To make the if statement check if the boolean is true, we could say if my first boolean is equal to true, but we can also shorten it to just if my first boolean, which will automatically check if it's equal to true. We can also add an else statement, which is kind of like an if statement, but we can only use it after an if statement, and it'll only run if the if statement doesn't run. The else statement doesn't need a condition because it always runs if the if statement doesn't. Inside of the else statement, we'll print out, using serial.println, else statement executed. Let's set my first boolean back to false and see what happens. As you can see, it checked if my first boolean was true, and it wasn't, so it went ahead to the else statement and printed out else statement executed. We can check integers, floats, and strings, just like we did with the booleans, using 2 equals to mean is equal to. Down here, let's type if my first integer is equal to 21, and inside of the braces, we'll print out 21. The last type of if statement is an else if statement, which goes like this. Else if my first integer is equal to 22, then we'll execute the code. Now, first we'll check if my first integer is equal to 21, and if it is, we'll do this. If it's not, then we'll check if my first integer is equal to 22. So these can't both run at the same time, but if the first one fails, we'll go ahead on to the second one, and inside of it, we'll print out 22. We can also add an else statement onto this, and inside of it, we'll print out not 21 or 22. Because if we get to this else statement, it means that both of these have failed. We can put in as many else if statements as we want, and it'll try each of them in turn. If one of them succeeds, it'll do what's inside of them, and then move on from this code block. If all of them fail, then we'll get to the else statement, and we'll do what's inside of it. Let's try it out. As you can see, it printed out 22, because that's what we set my first integer to, all the way back up here. Feel free to pause the video and try some other numbers to make sure you understand how this works. Let's try adding some code down here in the loop function. We'll start out by just printing hi, like this. Serial.println hi. When we upload our code, you can see that it keeps sending this message, hi, over and over again very rapidly. If we want to slow it down, we can add a delay using the built-in delay function, like this. Delay, and then inside of the parentheses, we can pass in a number of milliseconds to delay. 1000 milliseconds is a second, so if we pass in 500 milliseconds, then it'll delay for half a second. So it'll say hi, then delay for half a second, then say hi again, then delay for another half second, and so on. This is all great programming, but what the Arduino is really designed for is controlling other electronic devices. As you can see, the Arduino has a number of pin headers on each side, which we can connect wires to, and they can be used for either input, like a button, or output, like an LED. On the bottom side here, we have the digital pins, which go from 0 to 13, and can be set to off, which we call low, or on, which we call high. On the top side here, we have the analog pins, which go from A0 to A5, and they can be set to a range of values, so we could set an LED to a half or a quarter brightness if we wanted to. Let's start by wiring up a simple LED like this. As you can see, it has a longer leg and a shorter leg. The longer leg is for the positive side, and the shorter leg is for the negative side. I'll slot it into the breadboard with the longer leg on the right side. Next, I'll connect a resistor from the shorter leg to the blue line on the breadboard, which has a minus sign over here on the right. All of the pins on this blue line are connected, so we can connect a black wire from one of the pins on this minus side to one of the ground pins on our Arduino. The last thing we need to do is connect a red wire from the other side of our LED, which is the positive side, to pin 0 on our Arduino. Now we can control our LED using digital port 0. Our sketch has a lot of random stuff in it now, so let's create a new one. We can go to File, New Sketch, or just hit Control-N. Let's start by creating a variable that will contain the port we connected the LED to. Up at the top, I'll create an integer, because this is just going to be a number, called LED port, and set it equal to 0, because that's where we connected the LED's positive LED. Remember that the pins on the Arduino can be used for either input or output. Because of this, we have to tell the Arduino which one we'll be using a pin for. So in the setup function, we'll use the pin mode function to tell the Arduino that we want to use the LED port for output. First, we put in the port we'd like to set, and then we put in the mode. In this case, we're setting the LED port to the output mode. Then, we can turn the LED on or off by using the digital write function, because it's connected to a digital port. The digital write function also takes two arguments, the port, and then whether we should set it to off, low, or on, high. In this case, let's set it to high so we can see our LED turn on. To make the LED blink, we can use the loop function as it runs over and over again for as long as the Arduino is on. First, we'll wait for 1/10 of a second using delay 100. Then, we can turn the LED off using the digital write function, telling it to set LED port to low. Then, we can wait again. This time, let's do 1/4 of a second, and then use digital write again to turn the LED port to high. As you can see, the LED turns on for 1/10 of a second and then off for 1/4 of a second. It's a little bit hard to tell exactly how long it turns on and off for, but we can see that it stays off for a little bit longer than it turns on. Let's add a button, which we can read the value of in our code. First, I'll connect a button to the breadboard, making sure it spans the gap in the middle and that all 4 of the leads are connected to holes on the breadboard. It's in the middle because we don't want the leads on this side and this side touching, or it'll mess up how our button works. Next, I'll connect a resistor from the right side of the button to the blue line on the breadboard. Then, I'll connect an orange wire from the left side of the button to the 5-volt pin on the Arduino board. The last thing to do is connect this green wire from the back right side of the button to port 1 on the Arduino. When the button is up, no electricity will flow into the green wire because it's connected to ground. However, when the button is down, electricity will flow from the Arduino's 5-volt port through the button and into port 1 on the Arduino, allowing us to see that the button is pressed in our code. Speaking of buttons, if this video has been helpful to you so far, please tap the like button. First thing we want to do is to create a variable that will hold the pin we connected the button to, just like we did with the LED. I'll create an int called button pin and set it to 1. Then we need to set the pin mode of the button pin, just like we did with the LED. But in this case, we'll be setting the pin mode of the button pin to input, because we'll be reading the value of the button. Check where the button is pressed. We can create an if statement that reads if digital read, because we're reading the value of the port button pin. So this is the value of the button pin. And then we can check if it's equal to high. So we'll only run what's inside of these braces here if the button pin is on, which means that the button is pressed down. Let's move the code for blinking the LED inside of these braces, so that we'll only blink the LED if the button is down. A handy shortcut for moving code like this is to hold down the Alt or Option key and then use the arrow keys to move the whole block of code you have selected up and down. To make the LED blink faster, let's set both delay functions to 1/10 of a second, instead of having one as 1/4 of a second. We don't want the LED to remain on if the button is unpressed, so let's add an else statement, and inside of the else statement, let's use a digital write to set the LED port to low. Now, the LED only blinks when the button is down. Otherwise, it stays off. This was just a very quick overview of the basics of Arduino programming. If you want to learn more, check out my channel, Saber C++. Thanks for watching.